Hey everybody, how's it going? Today we're going to talk about a couple of problems from the solution set. From the Ticket to Leave on 5.4. There were two problems, number 4 and number 5, that seemed to give students the biggest issues. So, without further ado, let's cover them. In the first question, it says, find the value of x. So we want to find that x value. So what I did here was I redrew the original triangle. Okay? Notice that I color coordinated things to try to help out. Okay? So what we always remember on how to label the triangle, right? We always look at the right angle, the side that is opposite the right angle is the hypotenuse, so that's technically C, right? And then 69 degrees, we look opposite to it, so this becomes the opposite side, which then leaves this 6 as the adjacent side. So it is important to redraw and label the sides appropriately. Remember, you generally want to start, labeling the hypotenuse and then each leg, the opposite, and then lastly, the adjacent. Okay? So once you've redrawn it and you have your labels put in place, right, because this we can just call height, right? We reference SOHCAHTOA. So SOHCAHTOA, SOHCAHTOA, TOA. You see how we have something that we want in the opposite and a value for the adjacent. So I used TOA. TOA. Opposite over the adjacent. So we use TOA, and I just substitute the information into the correct places. So the tangent of 69 is x, the opposite, over 6, which is the adjacent. We then multiply both sides by 6, and we report the exact solution. Then we make sure to report the approximate solution rounded to the correct decimal place or point. Okay? In fact, let me change that real quick. We'll just cut this out and put it in place. Okay. So why did I round it to the tenths? Well, because it told me. Be careful about rounding. What I actually did was I put this right into the calculator, literally writing 6 tan 69, and then hit enter. Okay. So remember, it said to the nearest tenth, so I rounded to the nearest tenth. All right, number 5. It says a skateboard ramp is 18 inches high, and you'll note that I put that in brown because I figured, like wood, so maybe help out. And rises at an angle of 20 degrees. So you can see by the blue arrow here that I'm rotating up this way. Okay? Is that clockwise or counterclockwise? That's right, it's counterclockwise, right? So we write the original and we label all the sides appropriately. And that's what I did. The height has to be 18, that's the distance here. And we know that the base of the ramp is what we're looking for. So I labeled that D for distance. Okay? The one thing we do know is that the angle that it is rising is at 20. So now that we have everything put into place, we reference SOHCAHTOA, and again, this is a tangent. It has opposite over adjacent sides, so I placed all the correct information in the right spots, and then we multiplied both sides by d, and then we divide both sides by the tangent, the whole thing of 20. Not just 20, not just tangent, we divide the whole thing by tan 20. Okay? So, once we have that, I've reported the exact solution. So remember, this is the exact solution. This is the approximate. So I literally typed the exact solution right into the calculator. And how I did that is, if you take a look at how I would type in 18 divided by the tan of 20, for example, I would input it into the calculator as such. I would write 18, then I would make my division, right? Then, just in case, okay, just in case, to be really careful, make a parentheses, then tan, then it will make its own parenthesis, put 20, and put 2 parentheses. This is what I input into the calculator. And then round. Okay? So hopefully that makes things a lot clearer with the problems that you had some issues with. If you let me know, please let me do. Remember to leave a comment in the assignment section. The assessment section, not the assessment, the assignment section of this assignment. So hopefully that makes more sense to everybody. Let me know. Thanks. Bye.